Hi all, welcome to TutorSpot. In this video, let's discuss about input buffering. In compiler design, the lexical analyzer scans the input from left to right, one character at a time. To achieve this, it uses two pointers. First is the begin pointer, which marks the beginning of current lexeme, and the second is forward pointer to keep track of input scanned. For example, let's consider int a. Initially, both the pointers point to the first character of the input string as shown here. Here is the begin pointer and also the forward pointer. Then the forward pointer moves forward to search for the end of the lexeme. So the forward pointer moves ahead from I to n and then n to t, and then in this stage, when it encounters the white space or blank space, it indicates the end of the lexeme. Here it indicates the end of the lexeme int. So the pointers move forward to the start of next token by ignoring the white space. So the input character A has to be read from the secondary storage, but reading in this way from the secondary storage is costly. So buffering techniques are used. So let's discuss input buffering now. Input buffering is a technique where the compiler reads input in blocks into the buffer instead of character by characters from the secondary storage. The lexical analyzer then processes characters from this buffer and improves the performance. We have two methods of input buffering. First is the one buffer scheme and the next is two buffer scheme. Coming to the one buffer scheme, in this scheme only one buffer is used to store the input string. But the problem with this scheme is that if the lexeme is very long, then it crosses the buffer boundary. So here a single buffer is used to store the block of input. The forward pointer scans the characters within this buffer until the end of the buffer is reached. But the problem with this scheme is, if your lexeme is longer than the buffer size, part of the lexeme may cross the buffer boundary. Refilling the buffer overrides the beginning of the lexemes and it causes errors. Next is the two buffer scheme. In this scheme, initially both the beginning pointer and forward pointer are pointing towards the first character of the first buffer. Then the forward pointer moves towards the right in search of end of lexeme. As soon as the blank character is recognized, the string between the beginning pointer and forward pointer is identified as corresponding token. So, this two buffer scheme is used to overcome the limitations of one buffer scheme. In this method, two buffers of equal size are used to store the input string and the first buffer and second buffer are scanned alternatively. When the end of the buffer is reached, the other buffer is filled with the next block of input. Initially, both the begin pointer and forward pointer are pointing to the first character of first buffer. Then the forward pointer moves towards the right in search of white space or sentinel character. The sentinel character is EOF marker. Then the analyzer switches to the other buffer. That means the second buffer. Same as the first buffer, if the second EOF is obtained, then it indicates the end of the second buffer. Alternatively, both the buffers can be filled up until the end of the input program and the stream of tokens is identified. So let's see an example for this. Here in this example, we have the string int I is equal to I plus 1 and j is equal to j plus 1. And we have two buffers, buffer 1 and buffer 2. In buffer 1, we took int I is equal to I plus 1. And in the buffer 2, j is equal to j plus 1 value. So the beginning pointer and forward pointer are pointing to the first character of the first buffer initially. Then the forward pointer moves towards the right in search of white space or some sentinel character. Here the white space is obtained. Here the token int is obtained and the begin and forward pointers are pointed to I. And again the forward pointer will move forward in search of EOF or white space. The EOF is obtained here. So the token I is equal to I plus 1 is generated. As EOF is obtained here, the analyzer switches to the second buffer. So same as the first buffer, if the second EOF is obtained, then it indicates the end of second buffer. So begin pointer is pointing towards j and the forward pointer will move ahead in search of white space or EOF marker. So here in the second buffer EOF is obtained. So the token j is equal to j plus 1 is obtained and the required stream of tokens are identified. The only problem with this method is that if the length of the lexeme is longer than the length of the buffer, then scanning input cannot be scanned completely. means larger buffers consume more memory, and also incorrect handling of buffer refills may lead to errors resulting in management complexity. And lexeme boundary issues also arises if the lexeme exceeds the buffer size, and scanning may also fail. And coming to the advantages of input buffering. This input buffering is a crucial optimization in compiler design. By reading input in larger chunks using one buffer or two buffer schemes, it reduces I/O costs and improves efficiency and simplifies lexical analysis. While buffer size and management must be carefully chosen to avoid errors, the advantages generally outweigh the disadvantages, making input buffering an essential technique in modern compiler implementations. This is all about input buffering. Thank you.